Hello students, in this session let us solve numericals based upon the calculation of power output required to achieve some speed in the vehicles. The previous class we already discussed on the what all the various resistance that are causes hindrance to the motion of the vehicle. So some of the resistance that will include, the first one is the rolling resistance, that can express resistance that is caused due to the undulations in the road surface, and it can be determined using the relationship Pf is equal to mfg, where m is the mass of the vehicle, f is the friction that is developed on the pavement surface, and g is the acceleration due to gravity. The second resistance is due to the friction that is developed between the moving vehicle and the air, which is traveling in the opposite direction, and that can be represented in P suffix a and is calculated as CAB square. So see where C suffix A is the coefficient, and the A is the front projection area of the vehicle, and B is the speed at which the vehicle is moving. And the third resistance, we have the grade resistance, which is due to the presence of the grade. So grade resistance can be because of the upward gradient that is provided. So for the upward gradient, the resistance calculated will be positive, and that means to say that we require extra energy to move your vehicle in the upward gradient. Whereas in the downward gradient, and it is represented in the negative direction, now calculated using the formula mgi divided by 100, where m is the mass of the vehicle and g is the acceleration due to gravity, and I is the percentage grade that is provided, and I value is positive if it is upward gradient and it is negative value for the downward gradient. And then another next fourth resistance is due to the inertia forces due to the acceleration and deceleration of the vehicle. So that is the additional force which is required to start the vehicles from zero to the some speed, to achieve some speed. Okay, and also to suddenly if you want to stop the vehicle. So what is the additional force that is required? That is denoted by letter Pj and calculated as plus or minus m into a. When it is accelerate, vehicle is accelerated, inertia force developed will be the positive, and for the deceleration the value will be negative. So that's the total resistance of the motion cause. Pp can be represented as Pf, summation of the all the resistance. Along with these resistance, we have one more resistance, that is the transmission losses. Okay, so this transmission losses also need to be considered when the total resistance is calculated. Usually, so that depend if the transmission loss is 90%, transmission loss is the 90% out of total power output generated. So only the 9.9% of the energy will be available. So that need to be considered, the transmission losses. So next, some of the note with respect to how to calculate the power output required. So what is the power required to resist all the forces in the moving vehicle? So that the power output can be calculated as Pp into V. So where Pp is the total resistance due to the motion, that is equal to sum of the all the resistance for the motion, into V is the speed of the vehicle, and that can be calculated as 2 pi Rwn 60 gt into Ga. And this formula, when the V is in meter per second, and usually if you convert the V in kilometer per hour, we know how that is converted, and we can take capital V is equal to 0.377 Rwn GTGA, where GT is the transmission gear loss. This will be given, the value will be given for you in the numerical itself, and G is the rear axle ratio, and once again the value will be given in the problem statement itself, whereas Rw is the component related to the tire deformation factor, and where gamma is the tire deformation factor, and R naught is the radius of the tire. So usually gamma value varies from 0.95 to 0.45 to 0.95.